Hi there everybody, it's the whole universe. Hope everything is fine. I'm a Rashman who brings follow the experience. And today we're gonna communicate with you about ML pipeline, about different types of stages that we can find during the ML system design. Yes, let's go to this coming up, as they say. First it is data gathering, then will be data cleansing, then will be outlier detection, then will be the feature engineering, then model selection, then testing, then fine-tuning, and then deployment, and also data documentation, and also some of the documentation, yes, of the process, and also different types of what can we find there? It is a maintenance. Yes, it could be nine stages or 7 stages, or you can use only 4 stages. You can say that data gathering, then feature engineering, then kind of creating, and then already deployment. Yes, it is different types of how we can describe the process. Actually, we will follow this line of 7 stages or 9 stages. Let's go communicate about it. First, it is data gathering. Data gathering, it is when you are doing some asking questions and also writing some information from logs. For example, you are gathering logs from your website or maybe from your social media, and then you are kind of scraping it, web scraping, social media scraping, and different types of gathering data from the sources that you already have. For example, you have the storage of the user data that they were doing something, maybe cookies, their cookies, and you have kind of data. If they allowed on the terms of use that yes, we can use it, yes, everything is fine, we kind of checkpointed and everything is fine. So if it is, then we can kind of gather the data. So data gathering could be also on the streets when you are asking with microphone some people, or maybe with some of the recorders, yes, and you are asking them questions about their preferences in music, in video games, and also in films and things of this nature. Actually, you can ask them, and then you gather the data, and you can put this on Excel or Anaplan, or maybe different types of data storages and data tables that you can have, spreadsheets and things of this nature. So data gathering, it is the first stage. Then it will be the stage of cleansing or cleaning the data. Cleansing or cleaning the data, it is when you fulfill some cells inside of your table or data, and maybe you do have some information inside of it, and you fulfill it with some probability, with some guess. It will be guessing moment sometimes, not the truthfulness fully. Maybe it could be the guessing with 85% of the truthfulness of the information. Actually, 85% it could be actually a nice percentage of your confidence that you will fulfill it, because when you are asking questions on the streets, then you maybe don't have full data, because some people answered this, answered that, then you maybe did not pick some information, and then you need to fulfill all the information, or maybe delete fully. It could be also cleansing, actually, because deleting, it is cleaning to something, need to do something that will fulfill every row or every column or every row in your table or data, if it will be the table or data, because it could be page, it could be different types of pictures and things of this nature, and in this stage you could also delete some pictures that are out of distribution, out of main distribution. Okay, next it will be the stage of our outlier detection. Outlier detection, it is almost the same as data cleaning, but actually it is a little bit another thing, because data cleaning, it is sometimes fulfilling the data of that is kind of already, we don't know what is inside of it, and we can guess only about it. And actually it could be guessed, or it could be kind of skipped, because it is cleaning of the data, could be skipped or deleted or something like this, or changed a bit, because not changed to kind of fraud the system, to change to make it kind of to delete something, to fulfill information, because sometimes you have the data that are kind of, imagine that you wrote wrote on your kind of writing, or maybe you have the data from your phone and you are doing kind of typos. It is errors, mistakes. You did mistakes and something, for example, you wrote not 67 but you wrote 6.7, or maybe you needed to write 6.7 but you wrote 67. Actually it is two different numbers, because one is greater than another in 10 times, and actually it could be outliers too. It is what I mean by data cleaning and data cleansing. Okay, and gathering the data, it is the stage when we already did gathering the data, then cleansing of the data, then outlier detection. Outlier detection, it is the task when we cluster the data by specific clusters, and then we need to delete some data, or maybe we need to decrease their influence, or maybe we can kind of not see the data that is out of distribution, that is outliers, that are anomalies and something kind of super mega deviated from the main distribution. Outlier, it is actually the data that is so super far away from the main distribution. Imagine that you have the things, for example, you have the data here and one data is here. Yes, it's out of distribution because it's so far away from it. If it is one, if it is kind of several, then it is already another cluster. Or it could be outlier cluster. We don't know. It is all about kind of our feature engineering kind of stage. It is not feature engineering, it is pre-feature engineering. And in this stage we use z-score, IQR, DADA, MOM, MAD, and also add-ONE, ONE, DONE, and also Kitsune network, and also one class support vector machines to detect the outliers. So we can use also 3 sigma rules. 3 sigma rule, it is kind of, we have the Gaussian Laplacian distribution here, normal distribution, and everything that is kind of further than 3 times sigma, and then it will be kind of standard deviations. Sigma, it is standard deviation, that everything that is further than 3 times standard deviation, then it will be outlier. Or maybe 5 sigma. 5 sigma, it will be really, Jesus Christ, super rare events. Actually 99.7% of the data lies in the main distribution, and it is in the 3 sigma. Here is 2 sigma, here is 1 sigma, here is the mean number, and here is the kind of, it is the expectation number, mathematical expectation, or maybe mean in terms of the statistics. Yes, and here is the 3 sigma. It is kind of super mega rare events. Okay, also we can use IQR. It could be 2698, I think so, 2698 of standard deviation of sigma. Okay, it is our outlier detection. Then we can use different types of deleting them and or influence weakening, or maybe we can change them by using Winsorizing mean. We can use trimmed mean by Henry Poincaré, or we can use Winsorizing mean by Windsor. It is when we use data, and here is replacing them by these things. Okay, and it is our algorithms. Then next, feature engineering. Feature engineering, it is the next stage when we use the data in terms of we describe them in terms of the, for example, you have the people who are from 7 years old to 18 years old each. Yes, it means that we use this data as the schoolboys and schoolgirls. If they are from the age of 21 or 22 to 60, then it will be really payful audience. Payful audience, it means that they can allow to pay for something. If they are 28 plus years old, then they know something about life. They already know their way, where they are going. Kind of, it is our social things they are saying to us, that 28 plus, they are kind of know about life something, and it's already nice. Also, we have the audience that is 16 years old to 30 years old, or maybe 16 years old to 29 years old, or 16 to 35. It is the young people, young adult people. It means that they know something about life and they can do something. It is kind of the generation of kind of, yes, working nice and something like this. Actually, it all depends, because we have different types of audience, we have deviated data and things of this nature, so it is the main law but not the rule rule at all. It is kind of, sometimes it is, but it is not, maybe. Okay, it is feature engineering. It is the process when we create length, width, height, depth, or also longitude, latitude, altitude, RGB, RGBH, CLH, CLH, SVH, SB, CMY, CMYK models of colors and different types of features for the data, and we describe it by different types of usages of variables that we have. Okay, it is our feature engineering. Then we are going to the model selection. Model selection, we are using different types of algorithms for, by the way, here is also clustering algorithms could be used, such as k-means, k-means++, k-means-sharp, robust k-means++, dbscan, hdbscan, cure, chameleon, clarence, fast clarence, fast pm, fast pm1, fast pm2, eager pam, dmv, cj, dmv, cv, ae, dmv, ssc, rcc, rcdr, cdr, sgd, drc, dec, homm, cor, depict, agnes, diana, fuzzy, c-means, k-prototypes, k-modes, and others. We can use their sting to grid-based clustering, em, expectation maximization, Gaussian mixed models, and etc. And also here we can use on the model selection, we can use different types of classification algorithms and also regression analysis algorithms. And if we need it, we can use also dimensional reduction, and here is dimensionality reduction could be used too, such as algorithms will be the way it is that is following. It could be our PCA, ICA, Fast ICA, LDA, NMF, TSVD, SVD, TSNE, Grand Prix, FA, EFA, UMAP, Uniform Manifold Approximation and Projection, PCA, KPCA, PPCA, Probabilistic, Principal Component Analysis, Kernel Principal Component Analysis, Independent Component Analysis, Factor Analysis, Exploratory Factor Analysis, T-Distribution, Stochastic Neighbor Embedding, and etc. Actually, it is different types of dimensionality reduction algorithms. And on model selection, we use different types of models to predict, forecast, guess, and also do the seeing the future, in extrapolating the data, what will be next, what will be on the next stage of our time series data. And here it is, our classification and regression analysis algorithms. Regression analysis, linear regression, linear regression, nonlinear regression, linear regression, nonlinear regression, polynomial regression, stepwise regression, robust regression, rich regression. Also, classification algorithms, KNN, K-nearest neighbors, also künstliche neuronale Netze, or it is our artificial neural networks, RNN, DNN, CNN, HNK, NP, LST, MAE, VAE, SAE, DAE, GAE, GAN, JAN, DFF, FF, DBM, BM, RBM, NTM, ESN, ELM, MLP, and others. It is our artificial neural networks. Also, naive bias, naive bias classifier, binary classifier, multi-class classifier, support vector machines we can use. Also, logistic regression, it is the equation of 1 over 1 plus e to the power of minus x. It is also logistic regression, multinomial logistic regression that we can use. Also, multi-class support vector machines, decision trees, random forest, this is ensemble of decision trees, and also XGBoost, CatBoost, XGBoost classifier, CatBoost classifier, LightGBM classifiers, and other features we can use on the model selection. Also, we can pick different types of transformers for NLP, NLU, NLG tasks. For example, ExcelNet, Transformer Excel, Bert, Roberta, Albert, Disalbert. Also, we can use GPT, GPT-2, GPT-3, GPT-3.5, GPT-4, ChatGPT, and things of this nature. Word2Vec, Doc2Vec, Item2Vec, Patch2Vec, Tile2Vec, Patch2Vec, Tile2Vec, Log2Vec, Item2Vec, recommended systems, yes, collaborative filtering recommended system, or maybe it could be content-based recommended systems, or it could be also hybrid filtering recommended systems, collaborative filtering, content-based filtering, or maybe it could be hybrid filtering recommended systems. Actually, it is the model selection. It is different types of algorithms, actually. It is the same as using different types of sorting algorithms, or cryptographic algorithms, such as, for example, sorting. Yes, merge sort, quick sort, bubble sort, heap sort, tree sort, radix sort, bogus sort, sush sort, haha, and also gnome sort, insertion sort, selection sort, and others. It is for sorting, or depth first search, breadth first search, brute first search, best first search for searching, or cryptographic Diffie-Hellman algorithm, SHA-128, SHA-258, SHA-256, SHA-384, or maybe others, Two Fish, Blowfish, Three Fish, Tiger, Whirlpool, Polybi Cipher, Caesar Cipher, Atbash Cipher, and others. It is actually for cryptography. It is almost the same as model picking or maybe model selection. Model selection, it is the process when we pick specific algorithms or create them. Then we are doing testing of them. It will be our 6th stage. Then on it is first, second, third, 4th, 5th, 6th testing of the things, testing and picking something. Yes, and actually okay, some numbers actually. Okay, and we will count then in the final. And then it could be testing of cross-validation, cross-entropy things and things of this nature. Then it will be fine-tuning when we do some sigma things, epsilon, upsilon, and things of the x, y, z, and things of this nature. We are doing some kind of scrolling them a bit, and also fine-tuning, yes, a bit our model, making them work better. Okay, and then will be deployment by using Docker, Kubernetes, Ansible. Also it could be Istio or Jenkins. Actually deployment, then maintenance on this stage, and then will be documentation creating. It is our process of creating our system. So thank you a lot for watching this video. Let's count our stages. First, data gathering, then data cleansing or data cleaning. Also outlier detection could be here, outlier detection. Then it could be 4th, feature engineering. 5, model selection. 6, it will be our 6th stage. It will be our testing. Then it will be a 7th stage. It is fine tuning. 8th stage, it will be our deployment. Then maintenance. Then it could be 10th stage of our already documentation creating. So 10 stages or 9 stages you can use with outlier detection, when outlier detection could be changed to, or maybe merged with the stage of data cleansing. You can use different types of them. Actually, it is the process and also outlier detection, and in this data gathering, in this stages, we can use also cold start algorithms or maybe cold start thinking, because it is all depends how many data you have on the first stage. Data gathering. Data gathering is one of the most important, and model selection and feature engineering. Feature engineering, model selection, and data gathering, one of the most important. And also fine tuning and testing and things of this nature. Actually, every step, each step is super important. So thank you a lot for watching. See you next time. You're a nice guy or girl, and improve still daily. Bye. You know many things about ML systems right now. Oh, by the way. Oh yes, it's time already. See ya next time. Bye.